I'm going to tell you about ongoing suction cup tagging of the whales here in Skjálfandi that I started last year. Maybe you've heard about suction cup tagging before because Mariana and international colleagues have been tagging whales several years before, primarily focused on blue whales, which maybe you're going to hear about shortly. But last year I started my own project, Suction Cup Tagging. And just as the title says, it's an ongoing project, so I don't have grand results to show you right now. But I'm going to show you about the process of the tagging and the basic but very cool data that the tags are collecting. And I also wanted to thank Alyssa Poldner because the other day she sent me all these beautiful pictures and videos. She was very good at documenting, and it made my presentation very good. So thank you very much in advance for that. So first, just about the tag. So I'm using a customized animal tracking solutions, or a CATS tag, and it has all kinds of sensors in it: depth, temperature, acceleration, GPS, and a hydrophone. And of course, you can change these sensors and set them in different ways depending on the situation. It's also fit with a corroding release mechanism. And I don't know, can you see? No, wait. Laser pointer. So here is the corroding release in silver. So what that does is it just basically dissolves in salt water, and it will release the tag after a certain number of hours. So I'm using the smallest or the thinnest corroding release, which is made to last about 12 hours. And then on the right, you're seeing the suction cups. So you're seeing the tag upside down. So it has 4 suction cups on the bottom. So you're literally just sticking it onto the back of the whale. And it has a magnetic control. So all the sensors can be turned on and off just with a magnet. So very easy to do in the field. And the main goal of the tagging that was started last year, it had 2 main goals. One was to start pinger entanglement mitigation trials. So if you've heard me talk before, you might have heard me talk about pingers in the past because I used pingers during my PhD project. They are the little devices that attach to fishing nets that make the sound to try to warn the whales to stop them from swimming through the nets. So the idea now is that first we tag the whale and then we do the pinger playback experiment so that we don't have to record the behaviors of the whale. The tag is doing all that work for us. And the other goal for last year was to identify active and resting behaviors. And that was Jean, who maybe some of you have seen her. She's back here working in one of the ticket centers. So this was for her master's thesis, also using the data last year. So the process of the tagging, so basically the tag is just on the end of an 8-meter carbon fiber customized Willem pole. So you can see the pole in the picture here, a few meters of it. And basically on the end is just like a plastic hand holding onto the tag. And basically the hand is holding it just tight enough that you can turn it over and it still holds. But as soon as there's some resistance from the suction cups, it's being pulled off of the end of the pole. And we're using what we were calling last year the 3-breath rule. So basically you need a whale that is calm and very cooperative, that is taking at least 3 breaths at the surface. So you need the first breath to say, okay, there's the whale, it's back at the surface. You need the second breath to get the zodiac in position parallel to the whale. And then you need the third breath to stick the tag on the back of the whale. And then in theory, you just stick it on. It sounds very easy, and I'm about to show you a video that makes it also look very easy. It's not that easy. And in the video, you do not see the first breath, so it's clipped just to be short. So you're missing the first breath, but you're going to see second breath as we're getting in position. Alyssa was driving the Zodiac very well for me. And then you're going to see third breath where I'm going to stick the tag on to the whale. So I hope, yes. So second breath, you'll see me nodding, yes, this is the one. And you have to be really quite close. So we're going nice and slow. We wanted to have a calm approach. We didn't want to be chasing the whale. And there you have it. Stuck it right on. You're going to see my very excited face in 1 second. I cannot believe it. Yeah. And so, yeah, it looks very easy. It's not that easy. But then I'll show you next that here's our whale. You're going to see the tag stuck on the back. Off into the sunset, the whale goes. Oh, yep. And we were very lucky that Alyssa had Maria Claro's drone. So you can also see from above what it looks like when the tag is stuck on the back of the whale. And what we really like to see from this is the tag is nice and straight on the back. So the straighter the tag is aligned with the whale, the better your data is going to be. And you don't have to do calculations for the tag being kind of off kilter. So now I'm going to tell you a couple of things about the whales that were tagged. So actually the first whale that we tagged was not in Skjálfandi. It was actually in Eyjafjörður during tag training that I was doing with Mariana's colleague, Jeff Schnitzler. He's from the University of Hanover. He's been coming for several years to assist with this type of tagging. So he was training me how to tag. And it was early in the season. You can see 30th of April was when we tagged this whale. And there was no humpbacks in Skjálfandi, so we had to move to Eyjafjörður so we could still do the training. And somehow, out of the handful of whales that were behaving very nicely at Eyjafjörður, the tag ended up stuck on the mystery whale, meaning it never lifted the fluke. Not before we put the tag on, not after we put the tag on. It disappeared. But I do think that this is a very recognizable whale, even without the fluke. So you can see it's got these marks on both sides. Some of them are maybe cookie cutter shark bites, which you're going to hear more about later. And also lots of scratches, so a pretty identifiable whale. So if somebody thinks they have pictures of this whale, I would be very interested to know. And just on the right, you're seeing the proof. There's the same tag stuck on the back of this one. But the Skjálfandi whale, we know much more information about this one. Tagged on the 26th of June last year by me with Alyssa driving, as I mentioned. John, the master student, was with us, and also a Nook internship student, so all-female crew on the boat doing the tagging. And so this is HRC MN 783, or Sauron, beautiful black fluke. Seen in Skjálfandi 2018 and 2020, and then last year again. And because we had that beautiful video from the drone, Maria could measure this humpback is 10.1 meters long. So kind of a typical humpback whale that we're seeing here. So then the tag is traveling with the whale for many hours. And then you got to get the tag back. So it is not live transmitting anything. So now the tag is going to fall off, and now you have to find it again. So it's floating with the VHF antenna up. And it's sending a ping signal that basically you have to listen to, just the same as if you've ever watched a wildlife documentary and seen like the lions with the collar, and they're using the tree, what I'm calling the tree, to find them. It's exactly the same thing, but it's for the tag floating in the water. So it's a VHF signal. And so you can see on the left, I think that's a Nook right now holding the tree for me. I don't know if that's what it's actually called, but that's what I'm always calling it. And I'm sitting behind her listening to a radio that's attached to it. But this has very long range, something like 6 kilometers. I've heard stories that Takashi, who is very good with this tagging stuff and coming here several years, he's heard it up to 10 kilometers away. So this is very rough positioning. And once you get closer and you have a strong signal with the tree, then you can see on the right, now I'm listening only through the radio. So now we're getting shorter and shorter range. As you're getting closer, the signal's getting stronger and stronger until you finally find it in the water. And I can tell you this is very hard. Tagging of the whale is very hard, but finding the tag is also very hard when you're only using the VHF signal. So the first tag that we put on in Eyjafjörður, because the whale went a long ways, actually out of Eyjafjörður, it took us 12 hours to find the tag. Yeah. And then the next time on the Zodiac, it took us 8 hours. So we shaved some hours off of there. I hope I'm not re-traumatizing anybody who was with me, because it was very difficult. And not only is it hard because you're finding this tiny tag just making a pinging sound, but sometimes it's also very distracting. So there was a lot of interest from other animals about what we were doing out there. This guy, very cute, distracting. And these guys as well, you're going to see in a minute. So you can see I'm trying to listen to the radio and pay attention to what's going on. But in a second, you're going to see what's actually going on. So yes, so the dolphins with us, very interested as well. And I was really hoping that it was going to be like a movie and the dolphins were going to lead us to the tag and it was going to be like a happy moment, but absolutely not. That did not happen. They led us very astray. So we had to really get back on track. So it was very distracting. And it's hard being out on the Zodiac, 8 hours searching for something and really questioning your decisions of how you got to this place. But when you actually find the tag, this is what it looks like. Yay! Very, very happy faces after all of those hours finding the tag. So we got the tag back, of course, both times. And when you get the tag back, that means you got these many hours of very valuable data back. So now you're going to find out what the whale was doing all this time. And now I'm going to show you a little bit of some of the basic information that you first calculate from the tag. So the very first thing that you do is calculate the dive profile. So this is the full dive profile. So for the whale in Eyjafjörður, the tag was stuck on just over 16 hours. So you can also, of course, zoom this in and find very specifically what was going on. But it's cool to see the full 16 hours of what this whale was doing and how many dives it took in those 16 hours. And also what's interesting is we know that we found the tag right floating at the mouth of Eyjafjörður. So the whale was headed out. And as the time goes on and the whale is, we're assuming, getting further and further out, the dives start getting deeper and deeper, over 100-meter dives. And that makes sense because inside Eyjafjörður it's quite shallow, but the mouth, I think, is about 200 meters. So now it's diving over 100 meters because it's in deep water depth. And the same profile, just to see the Skjálfandi whale, looks quite different, actually, which is very interesting. A lot of action in the beginning. The tag was on for about 13 hours this time. But then a lot of surface time, long periods of surface time, then all of a sudden extremely deep dive, about 15 minutes at a depth of more than 120 meters. Then again, a lot of time on the surface, another one of these very deep dives, and then very, very similar to the Eyjafjörður whale, before the tag fell off, very deep dives, over 120-meter dives, which is very interesting. The next thing you can ask with a script in this program called Eager Pro, the next thing you can ask it to calculate, or one of the next things, is, for example, the breathing. So then you can get the breathing rate of the whale and the surface time. So now this is zoomed in. This is going to be, the next graphs are just the Skjálfandi whale. So now this is zoomed in, so you're just seeing the first 2 hours of the tag. And then the blue dots, we were saying, okay, put a mark everywhere that the whale was taking a breath. And then you, of course, also have this in an Excel sheet or in some sort of table where you can then calculate, what's the breathing rate per hour, what's the breathing rate over the entire time. And this can be used for some different things, which I'll mention later. The third thing that is very important for here and interesting is the lunge feeding. So now we've ran the script to calculate based on what's called jerk, which is the change in acceleration in 3 axes. Then you can calculate a lunge feeding event, because when the whale speeds up and then opens the mouth, there's a very quick drop in acceleration. And so that, because of the drag of their huge mouth. So then that's everywhere that the blue dots are now in the first 2 hours. And what I think is also really interesting with the looking at, especially in this first half an hour, is how consistent the profile is. It's doing the exact same thing. It's going down, it's going a little bit up, somehow getting itself into position, and then it's lunging, coming up, breathing, and doing the same thing over and over and over again. So really holding a pattern for some time, just like we're seeing at the surface when we're out there. And then you're seeing a change in the pattern, and then picking up a pattern again once it's at a later stage. The last thing I'm going to tell you about the tag data collection is that it also has a hydrophone, which is really cool because sometimes you get very loud vocalizations because the hydrophone is literally attached to the whale. So I hope this is going to work. Can I just go ahead? Yep. Hopefully you can hear. yeah, so really cool. And I have many other vocalizations from the whale in Skjálfandi. And what is also very interesting about the fact that we got all these vocalizations is that maybe this could have a behavioral context, which we're going to investigate. Because if you can see in this video, look at the first whale, watch the fluke. White fluke, not our whale. There's our whale. See the shiny tag on the top? So while we were out there, it spent quite a lot of time with a second whale. Not when we tagged it, but shortly after we tagged it, it sped up, swimming south into the bay, and joined another whale. And then we started getting all these vocalizations on the recording, which is really interesting and something that is on the list to do next, which is my last slide of what comes next. So of course, there's many things that you can do with this tag data. Like I was just saying, the matching of the behavior and the sound data to investigate behavioral context of the vocalizations is very interesting. Also, the breathing rate data, Maria's using it now to calculate field metabolic rates of different species and look at the effect of body size. So I'm happy to have other people using this data. And also, as a whole, at the research center, and if anyone else has ideas, we're really interested in pairing all kinds of data collected. So we're getting this fine scale behavior from the tags, which is matched with the photo ID, which can be matched with the photogrammetry, potentially matched with biopsies, or even on the suction cup. Maybe you saw in the very first picture on the bottom of the suction cup, it kind of looked dirty. That was actually skin from the whale. So actually, often when it's falling off, there's like sloughed skin on the suction cups where you might be able to send that to a lab and determine the sex of the whale. So all of this put together can really give a holistic picture of the whales here. And actually, more tagging should start next week. So I mentioned Takashi, Dr. Takashi Iwata. He's from Japan. He's been coming here for several years tagging, and he's coming next week to assist with this. So if you see this green tag or any tag-looking thing stuck to the back of a whale, I'd be very happy if you told me that you saw it and where. And especially if you see it floating in the water, please take a position and tell me. Or if you have the means to pick it up safely, please don't run it over. But if you have the means to pick it up safely and you want to pick it up and call me and tell me that I don't have to spend 12 hours searching for it, I will owe you, and we can decide later what the payment would be for that. So thank you very much, and thank you to all these people who have been assisting with this or putting equipment or assisting with field work. So thank you very much.